A question that arises quite often and actually should be asked is there any science behind what we do at an Oasis of Healing? And absolutely, there's not only science, but there's another thing called common sense that one develops just from having been alive long enough on this planet to understand what they're seeing, observing. They've had enough experience. And so being an organism that we are, and you, having been alive long enough, you'll realize that all creatures eat food, have different dietary requirements, right? So dogs have a different dietary requirement than a giraffe. Yeah? And you couldn't get a dog to eat giraffe food, and you couldn't get a giraffe to eat dog food. So they're guided by instinct. Unfortunately, we're not, because we lose instinct. We lose our instinct early on in life because our parents tell us not to be instinctual, but rather to be culturally appropriate. And so we learn whatever culturally appropriate behaviors we need to engage in order to be likable and successful and all that in our environment. And part of that culture, and at the centerpiece of all cultures, is the cuisine. All right. Now, animals, all creatures, don't have to be told what to eat, as you know, because they instinctually know what to eat. We don't have that, and so therefore we are usually find ourselves as adults or teenagers, at least, eating a specific way that we grew up eating. And that could be, in certain villages in China, that might be eating live monkey brain, and in Tennessee that might be eating bull testicles, and whatever it is that you grew up with is going to be what you love and you've got to have. And so that's really all has to do with appetite, not with hunger. Okay, so hunger is a natural physiological set of responses to an energy or nutrient deficit. And then you engage in the behaviors to acquire the appropriate food or nourishment. And then once you've satisfied that, the eating behavior stops. It's no longer being stimulated. Now, appetite, on the other hand, has nothing to do with physiology. It has to do with your mind. And it's completely, totally opposite. You don't even have to be hungry or in need, or you don't have to have an energy or nutrient deficit to eat if you're eating from appetite. And you're going to eat not what's appropriate for your species and your physiology. You're going to eat what you've learned to eat, what you love to eat. Okay, and so they're completely different. Now, we know that all creatures are endowed with a specific anatomy and physiology to eat certain foods, digest them, assimilate them, and eliminate whatever waste there is. All right? Therefore, example, a giraffe with its long neck is going to be eating the leaves off of trees, just as a big elephant would be doing, right? Whereas an anteater with a long nose is going to be looking for ants in the hole with its nose. All right, so every organism, bacteria eat a certain way, flies eat food that we probably wouldn't eat, but they're designed by nature to deal with it. So then, taking that one step further, we realize that being creatures of the earth, then prior to all the technology, prior to all culture, everything, the earth did provide for us the nourishment we needed. It did not need to be altered in any way, including not heated up. Now, when we heat food, what happens? When we heat something, we change it chemically, all right? So you put your finger in a fire and it's gonna burn. The reason it's burning is it's destroying the tissues, all right? So you don't do that. And your clothing that you like, you don't put in fire. And if you have any money, you're not gonna put that in fire. And so anything that you value, you're not going to put in the fire, because fire is destructive. It's clear, it's obvious. All right, so for some reason we came to the conclusion that we needed to put the nutrients that nature designed for us into fire, and we do that. We call it cooking. All right, now, so cooking does change it. It changes the chemistry, changes what we started with. So if you were to do a chemical analysis on the food brought into the kitchen, and then a chemical analysis on the food that you're taking out of the kitchen to serve to people, you'd find that they're completely different, completely different. They've changed. And it's called an endothermic chemical reaction. All right. There are exothermic chemical reactions, exo going outward, endo going inward. So an exothermic would be you put two chemicals together and they blow up. That's exothermic. An endothermic is you put heat in, and that gives the energy for the chemical changes to take place. So it's an endothermic chemical reaction. Nevertheless, you wind up with something different than it was initially. And what it was initially was produced by Earth under the auspices, under the guidance and intelligence of God, and was absolutely what we needed. And in that tomato is not only lycopene, because if you saute the tomatoes long enough, you'll get more lycopene. Yeah, but there's no lycopene trees, right? We don't eat just pure lycopene. We get it right next to beta carotene, right next to the lutein, right next to ascorbates and fibers and calcium and magnesium. It's all put together in amino acids. It's all put together in a perfect amalgamation, a perfect synergy that is appropriate for whatever organisms will eat them. So it's no single nutrients grow. Anyway, so that's it. So just without the science, just understanding that, well, yeah, of course, yeah, we couldn't have gotten to where we've gotten if we didn't have the appropriate food already prepared for us by nature. All right, so that's a given. Now, but what's the science? Well, first of all, we've got to look at the anatomy and physiology. If we look at the anatomy and physiology, it's going to tell us anatomy is form and physiology is function. All right, so form defines function, function is defined by form. All right. So if I have wings, I'll fly. If I have gills, I'll breathe in the water, etc. It goes on and on and on. So when we look at animals that were designed to eat other animals, they have a specific anatomy. First of all, they usually have a snout. If they're mammals, we're talking about mammals and reptiles. They have a snout. Their jaws only move up and down. They have no cheeks because they have to be able to bite a neck and kill the animal or whatever they're going to eat, just chop it. All right, and they don't chew. They don't have flat teeth, and they don't grind and chew and swallow like that. So they don't have lips and they don't have cheeks, and they have long, thin tongues. Their teeth are sharp. Their saliva doesn't produce any real enzymes, and their digestive tract is rather short and straight comparatively. All right, so if you think of someone's trunk being, from here to your pelvis, right, the trunk of your body, your torso. The intestines of either a scavenger like a dog, which is a wolf, fox, hyena, and your collie or your poodle. Their digestive tract is about 3 times the length of their trunk. It's kind of long, but it's only 3 times. And remember, it's straight and not convoluted. And why? Because eating flesh or eating anything like that will putrefy very quickly. So it has to get in and get out as soon as possible. Their livers produce an enzyme called uricase, which breaks down uric acid, which is a byproduct of breaking down amino acids and nucleic acids. So the uricase takes one of the final products of uric acid and turns it into something called allantoin, which comes out in the urine. And they don't sweat; they pant when they're hot, and they're equipped to kill. They can kill. With their jaws and with claws, they can kill. So now, the carnivore, which is the cat, panther, tiger, lion, and your house cat, they are obligate carnivores. They must eat an animal, and they must eat it alive. They like it alive. Now, when you domesticate them and bring them, or put them in zoos and stuff like that, they wind up not being able to live the way they were designed to, and they'll wind up eating corpses. But they don't usually like to eat corpses in the wild. They just won't. So they eat it alive, and they usually eat. They eat the ovaries, the heart, the lungs, the intestines, and they drink the blood. They chew the eyeballs, and they eat all that stuff. And then they get to the muscle, right? And if they're full and they leave anything for the vulture, it's what you and I call steak. All right. Now, and they eat the animal alive. Now, The scavenger, on the other hand, the dogs, wolves, hyenas, all that, they can do that. They can kill, and they will. Like hyenas will get in packs, so will dogs get in packs and kill. Um, but they kind of prefer if it's already dead, so they can just eat it. They come upon a corpse and they'll smell it, and they can tell by the smell if it's still appropriate for them to eat. Because if it's gone too far, it's now really food for insects and bacteria, funguses, and things like that. It's no longer food for them, and they know that. And if we think of the scavengers, they all have snouts: bears, raccoons, rats, dogs. That's what they kind of look like. And they're scavengers, so they can eat anything. They can eat some plant, and they can eat animal, either one. But if there's no plants around or nothing that they like for example, bears like to eat berries and they like to eat honey and stuff like that. But if it's not around, they're totally equipped to kill and eat an animal. All right. So these are scavengers. All right. Now we're talking about mammals now. Mammals are warm-blooded creatures, right? Okay. So we're talking about basically like mammals. So the carnivores and the scavengers, and then there's the herbivores and the frugivores. Now, the difference in their anatomy and physiology is that their teeth are flat. They have cheeks, they have lips, like a horse has lips and cheeks. A horse goes, right? Cheeks. Cheeks are good because, when you ever see a dog eating and stuff falls out, it's got to pick it up again. For us, it's not going to fall out. We have cheeks. They're actually functionally, they're there to hold the food in. We grind it. And our tongues are not thin like the other creatures, but they're thick and muscular. Okay. We have a couple enzymes in our mouths. We have one that digests starch, and we have one that digests fats, lipase and amylase, amylase and lipase. But we don't have protease. We don't have in our mouths any enzymes to digest proteins, pure proteins. And then we have our digestive tract is 10 meters or 30 feet long, which is about 7, 8, 9 times the length of our trunk instead of just 3. We don't have the enzyme uricase. We can't break it down into a lantolon. And we wind up getting high uric acids and gout and stuff like that. Anyway, so those are just some of the, and we sweat. Elephants sweat, horses sweat, cows sweat. Yeah, we don't pant. Right. So these are just some basic fundamental ones. Another one is that the lion, the one that eats the animals alive, their stomach, not their intestines, their stomach is much larger than other creatures. Why? Because they need to gulp, bite. Remember, they don't chew. They just bite it and then swallow it. And it's meant to accommodate lots of big chunks because they might not find food for a week or two. So they've got to be able to do that. And that's how they are. And again, their digestive tracts are short. They don't have much of what we would call a colon or anything like that. They just get it in and out. Now, the creatures like us, well, let's take the herbivore, like the cow, the horse, those kinds of zebras, moose. They have again very long digestive tracts. Don't have the enzyme uricase, and they were designed to eat plants, and they do. They eat plants. Now, as I said, all the creatures are eating out of instinct, right? We don't have an instinct anymore. We've been culturally perverted. So those are the two, basic groups that I wanted to discuss. Okay, so the anatomy and physiology and all that is absolute science. It's observations. Those are part of what we call medical sciences or biological sciences that look at anatomy and physiology, which is how you were designed to eat. Now, are there any other studies? Well, yeah, they look at studies, for example, the only large group of people that don't eat animals, an organized type of group, are the Seventh-day Adventists, right? They don't eat animals. However, they do eat. It's the same level of junk food that everybody else eats, right? Macaroni and cheese and pizzas and and things like that. There's just no animal flesh, right? But when they do large studies of 100,000, 200,000 people, and they look at them over long periods of time, 10, 20 years, and they find that, and they compare them to the same group of people, similar group of people that eat regular diets, they find that the ones that don't eat animals have a significantly less all-cause mortality. That means mortality from heart attacks, strokes, CFCs, whatever. Cancer, what they call cancer, it's CFCs, even though they're eating the junk. That's pretty amazing. So there's those kinds of studies there. Now, how about what we call raw. And remember, I don't like the word raw because it sounds painful. I like the word real. So there is a Dr. Luigi Fontana, who's an MD, PhD. He was at Washington University in St. Louis, and he did a study where he took two cohorts. One was, I think, aged 18 to about 80, and they had eaten nothing but uncooked food for at least 3.5 years. Some of them for 8 years, 10 years, 12 years, 15 years, 20 years. The other group, same age, same distribution, age distribution, but they ate regular food. And he just did blood tests and bone density tests and all sorts of things. He just wanted to find some fundamental differences between them. And what he found was, and what really struck me, was that the people that ate the uncooked food had undetectable CRPs. CRP is a biomarker for inflammation. It's C-reactive protein, right? And it is an indication that, the higher it is, you want it to be under 3, under 2, under 1, as low as it can be. Anyway, they had undetectable. The people that ate uncooked food, undetectable, whereas the ones who ate regular food had varying degrees of inflammation. Now, why is that important? Inflammation is the underlying adaptive physiological process of all degenerative conditions. Degenerative conditions, what do I mean? Stroke, you're getting degeneration in your blood vessels in your head, in your brain, heart attacks, arthritis, even Parkinson's, Alzheimer's, osteoporosis. I mean, it goes on and on and on. So these are all degenerative conditions. In other words, they're due to degeneration, right? But the adaptive physiology is a chronic inflammation.